Hello class, so today we're going to go through lesson 6.3.2. So yesterday, as you are familiar with, we did talk about the elimination method, and we went over that some. And so today's lesson is going to explore the elimination method more. And so what we want to be doing is we'll be reviewing multiplying both sides of an equation by a constant can create an equivalent equation. And some of you guys noticed that a little bit yesterday by multiplying something by -1 on both sides. And so the core problems we want to focus on today is 690 through 693. So in today's lesson, well, as I said in yesterday's lesson, we used the elimination method, and that is, in summary, right, combining two equations in a way that eliminated one of the variables. And we saw that in some cases that actually sped up the process a lot compared to the problem where we did a substitution and we had to deal with all these fractions compared to just elimination. We had no fractions or anything, and we quickly got to be x equals 2 yesterday. And so it can be pretty useful when something is in standard form. Remember, standard form is like ax plus by is equal to c. And so today, as you practice with some elimination method, some things you want to ask yourself or your teammates is how can you create one equation with only one variable? Right, because we want to try to see if we can eliminate one variable to solve for the other variables, and then we can plug in and solve for that second variable. So how can you eliminate one variable, and how do you know your solution is correct? In other words, right, you should be checking your work, put it into both equations, right? If you just do it into one equation, you may be correct that is a solution of one equation, but it may not be a solution of the second equation. So it's always good to check both equations to make sure that the solution is good for both equations. Some other questions you can ask yourself as you're going through this work is, for what kind of systems is elimination the best strategy? How do you know if you need to change one equation or both before combining equations? Because sometimes with the elimination method, by changing both equations some can help out. And what is the point of using the elimination method? And then also something else you might think about it as just an example. If 2x minus 7y equals to 10 is one of my equations, what is the second equation that would make this system of equations a good candidate for elimination method? Right, so if you know one of your equations, what could potentially cause elimination method to be a good method to use. And that's usually when you have the opposite of, like -2x or a positive 7y. As stated, your main goals today is to go over questions 90 through 93. And so question 90 here is going to have you set up a system of equations and try to solve using that system of equations. Once again, the elimination method is something of high value here, something that we're wanting you to be able to work on, and so hopefully you can do that some. And so let's also look. So we got 91, right? So 91 is going to be having us solve this other system of equations. How can we combine them, right? So yesterday, oftentimes we had equations where, we might have a y and a -y, and we would add those together, and the y would be eliminated. In this case, that's not the case. So you might want to ask yourself, well, what can you do to make it so you can combine those equations, right? So one quick hint is if we it's some multiplication, right? If you do something to one side of the equation, what can you do to the other side of the equation and make it true, right? So in this case, if you multiplied everything by 2, what would happen, right? And how would that change that equation, and is that a valid step to do? If so, okay, great. And how does that help us out moving forward? And that's going to be similar to what these other problems are going to be doing. Though sometimes, other than just multiplying one of the equations by a number, sometimes with elimination it helps to multiply both equations by something in order to have a variable which is easily eliminated. And so as you go on, use some good ones. 92 is kind of a fun one. People have sometimes struggled with this one. I've seen this at or similar ones as this put out as riddles on various places. So it's kind of a fun little riddle to do. And then 93, it's going to be using our distance times rate equals distance equals rate times time. Right. So with the 93 here, be sure to be take in consideration our equation of distance equals rate times time, and using some sort of elimination method with that will be helpful. So hopefully that's a good start for you and some good instructions. Like I said, 90 through 93, and hopefully it be good, and hopefully this is helpful to having some of these instructions from me, even though I couldn't be there with you today. And I hope you have a great day, and I'll see you all tomorrow.